If you're an airplane nerd, you've probably heard of a plane called the Harrier. If you haven't, well, the Harrier is a subsonic multi-role fighter developed by Harcus Italy in the 1960s. The unique thing about the Harrier is that it was the first successful VTOL aircraft. Yes, the Russians had VTOL aircraft, but none were used to the extent of the Harrier. Achieving VTOL was no easy feat, however. Precariously balancing a 30,000 kilogram machine on 4 columns of air is complex and dangerous. On many occasions, Harriers have flipped while attempting vertical takeoffs and landings, crushing the pilot. But there are more dangers to VTOL aircraft than the balancing act. Something that almost every VTOL aircraft has had problems with is something called a pop stall. More commonly known as compressor stalls, it's a dramatic decrease in compressor efficiency, which leads to the loss of thrust in an aircraft. There are many causes of a compressor stall, but today we're just focusing on the type that affects VTOL aircraft in particular. Something important to understand about VTOL that is crucial in the understanding of pop stalls is how jet engines produce thrust. Most jet engines take in air from the front air intake, compress it in a series of compressor blades, and then burn it explosively, producing thrust from the expanding air-fuel mixture. What's important here is that the air going into the engine has to be cold. Hot gas is much less dense than cold air, so if a plane ingests lots of hot air, it causes the compressor blades to have a sharp drop in efficiency. Worst case scenario, the lack of dense air means that too much fuel is added relative to the amount of air in the combustion chamber, which causes this to happen. Unburnt fuel now exits through the exhaust, producing large flames. This is quite bad for the health of the engine, and it makes VTOL landings even more dangerous. How? When a plane comes in for a vertical landing, the hot gases being expelled from the engines can rebound up and into the air intake of the plane, causing a pop stall. Losing thrust while high in the air means you will drop like a brick, since wings are useless while stationary. There are a few planes that have had problems with these pop stalls, but there is one plane that you may have never heard of before that has especially big problems with pop stalls. If you're a massive plane nerd, you may know about the X-32. If you don't, well, the X-32 was Boeing's submission to the Joint Strike Fighter program in 2001. It's a supersonic, multi-role VTOL aircraft designed to take the place of the F-18, the F-16, and the Harrier, among others. One of the issues with the X-32 that may have caused it to lose the JSF competition was the fact that it could not safely perform vertical landings or takeoffs while in its stock configuration. The X-35, Lockheed Martin's submission, which would win and later become the F-35, could do VTOL landings and takeoff in the same configuration it was when it left the factory. And even after modifying the X-32 for VTOL, it still suffered from issues with pop stalls. And since the X-35 used a cold air lift fan, it did not suffer from pop stalls. Another solution to pop stalls is to use a hover pit in which the aircraft would land on to keep hot gases from rebounding to the engine. Of course, it would be very hard to install one on an aircraft carrier, but until another solution arrives, hot air lift nozzles will be very dangerous.